Hi, this is Francis with my recycling presentation on getting hydroelectric power by retrofitting already existing dams. In the US, 12% of our primary energy consumption came from renewable energy in 2020. Of that 12%, 22% was hydropower. Some of the biggest power infrastructures are impound dams that generate electricity. It is also one of the cleanest sources of energy. The Grand Coulee in Washington state provides 35% of the entire power supply in our Pacific Northwest. Conventional electricity from fossil fuels begins with the extraction of non-renewable natural resources, such as coal or oil, and has to be transported to a powerhouse. In the powerhouse, electricity is created by burning fuel to heat water. When water evaporates, it spins a turbine, which powers a generator and creates electricity. Hydropower works similarly, except you aren't burning natural resources for fuel. And unlike fossil fuels, you don't need transportation because the power is created right at the source. And it's the gravitational energy of a body of water that does the work. Therefore, no CO2 emissions are created during the process, and there is less energy wasted compared to other forms of energy, which is what makes it highly efficient. The biggest power plants are those of impound dams. These have large concrete barriers that hold back the water weight and control the flow. Water travels down large pipes called penstocks and spin a turbine in the powerhouse. This powers the generator, which converts the energy to electricity. They can be gravitational, buttress, or arch dams. The type of dam built depends on the site's geographical location as well as topography. Run-of-river tends to be more gentle on the environment. It is also known as a diversion, as only a portion of the river is diverted to a high ground holding reservoir, which runs down the penstocks, and in the powerhouse the turbines spin the generator, which produces electricity. These can still produce a lot of power without creating a total blockage of the river. Pump storage works like a rechargeable battery. It can be open or closed loop. When energy is needed, the top reservoir releases water down into the powerhouse through the penstock. The turbine spins the generator that creates energy, and when demand is low, however, the water is pumped back to the top reservoir for when it is needed again. It can be coupled with solar panels or wind turbines to avoid the use of fossil fuels. Pump storage can be quickly released or shut off to accommodate energy spikes, so it's only on when needed. Some of the adverse effects of large dams include displacement of people, land, and aquatic animals, and when dams fail, they can create big issues for those living near them. Dams can block the migration of fish that swim upstream to their spawning grounds. It also blocks sediments from reaching other parts of the river that provide nutrients. Mosquitoes can also be an issue depending on the type of power plant, as standing water is ideal for their larvae. There is a way to harness the kinetic energy of water while not completely devastating the environment, and that is to upgrade old plants with newer and more efficient equipment and retrofit already existing non-hydroelectric dams. But also important is to remove dams that are old, unsafe, and unneeded that are destroying their environment, and collaboration between different scientific backgrounds should be encouraged and expected when placing big unnatural structures in natural environments. Although the process is timely, the idea is simple. You make a hole in the dam and add penstocks, a turbine, and a generator. Hydropower is also one of the cheapest sources of energy, costing 5 cents per kilowatt hour on average, and can last up to 100 years. They are low maintenance, and at the right location, power is consistent. There are also solutions to many of the adverse effects of dams, such as fish-gentle turbines, fish ladders, and bypass tunnels for sediments. There are over 92,000 dams in the United States, and only 3% of those dams produce power. Many of these dams are used for irrigation, water supply, flood control, recreation, and fish breeding. Of these dams, approximately 54,000 could be retrofit for a megawatt or more. This method is less invasive on local animal and plant species compared to building a brand new dam, and it is putting an already existing dam to better use. One case study is the Red Rock Hydroelectric Plant in Pella, Iowa. It was a standalone dam built for flood control before it was retrofitted with 2 identical Kaplan turbine generators and penstocks. It can produce up to 170,000 megawatt hours of electricity annually to power about 18,000 homes. Additionally, Open to the public are picnic shelters and fountains, a playground, an extended bicycle and walking trail, and it still serves its original purpose. A second case study is the Kennelton Hydroelectric Facility project located on the Ohio River near Kentucky. It can generate an average annual output of approximately 458 million kilowatt hours. It is a run-of-river plant. Recreationally, Kennelton Pool is popular for boating, hiking, picnicking, and fishing. Not all dams are suitable to retrofit, and many old and unsafe dams are better for the environment if they are removed. American Rivers is an organization that wants to remove dams to bring life back to the rivers that are negatively affected by such dams. Environmental groups and energy companies reached a landmark agreement in 2004 with the Penobscot River Restoration Project. This project was completed in 2016. The river flows through Maine and connects to the sea. It has a stream-like bypass channel around a dam to improve fish access and movement. Fish populations have rebounded after only 3 years of removing 3 existing dams, while also providing more clean energy by upgrading 6 other already existing plants. Collaboration for this strategic project was important in its success to bring a river back to life while creating more energy. Government is also getting involved to provide better sources of energy. For instance, America's Water Infrastructure Act of 2018, sponsored by Senator Amy Klobuchar, became law. This law will modernize authorizations for necessary hydropower approvals. It will promote hydropower development at existing non-power dams and closed-loop pump storage projects. It will develop a list of existing non-power dams that have the greatest potential for hydropower development. There is also the 21st Century Dams Act, which was introduced to the Senate by Representative Annie Kuster and sponsored by Senator Dianne Feinstein in 2021. So far, it has been read twice and referred to the Committee of Environmental and Public Works. This bill seeks to remove abandoned, unsafe, or no longer useful dams. It also would create a committee to assess what dams would be well suited to be upgraded, repaired, or retrofitted for hydropower production. This bill takes into account the safety of people as well as environmental improvements, including fish passage, environmental flows, water quality, temperature, and dissolved oxygen upgrades. Government intervention is important because renewables are more attractive when the cost of oil goes up. However, we subsidize fossil fuel companies in the billions, which makes their prices stay relatively low. The cost is pretty high, we just don't see it directly. We are subsidizing fossil fuels more than $20 billion annually. That doesn't take into account indirect subsidies such as military spending to protect oil assets. We have begun subsidizing green technologies at a fraction of that of fossil fuels, mostly in solar panels and biofuels. Hydropower is being overlooked in development and research, despite being one of the most efficient forms of renewable energy. I am interested in hydroelectric power because I think it's important for the US to be power independent. As of today, in March 2022, our decaying relationship with Russia has shown just how important that is. Dams as water storage are also important, as climate change will cause water scarcity in many places, which will affect food production. And unlike other sources of green energy, I appreciate that dams can also support recreational activities. Having plant life grow around these bodies of water is great because plants, especially canopy trees, they cool areas underneath, they clean the air by capturing carbon dioxide called carbon fixing. They home many ecosystems. They keep our soil healthy to avoid desertification, as well as filter and retain water. Unlike fossil fuels that require the clearing of trees for mining or drilling, being around a body of water encourages plant growth. I also like that dams don't require them to be spread out across a lot of land that could be used for growing food or housing people and animals, as well as creating a reservoir to hold on to water until it is needed due to droughts, though severe droughts and low rainfall will lower the efficiency of power creation. Dams can also provide flood control. Projections show that in some parts of the world, storms will be stronger and constant flooding will become the norm, even here in the US. As of now, there is no one solution because of different geographical differences. But luckily, there are green options for every part of the country. For example, if we look where we get the most sunshine, solar panels are a great option. And looking at a wind mean speed map, wind turbines make sense. And in areas that expect floods and hurricanes, if we look at non powered dams that are already existing and could potentially create 1 megawatt of power or more, we can retrofit. In order for us to be energy independent and do it in a sustainable way, we have great options. But hydroelectric power should not be overlooked. Retrofitting existing dams is less harmful than building new power plants. Upgrading older plants will make them more efficient, and removing harmful dams will be better for our environment. Dams should be done with integrated design, which we just learned about, with input from architects, engineers, Department of Parks and Recreation, as well as life scientists such as botanists, geologists, zoologists, conservationists, etc., so that the end result is done properly to avoid accidentally further damaging the environment while trying to save it. Thank you.